This week at Gadget Class, I've been testing iGaging's new CoolantCal. This is a coolant-proof digital caliper in the sub $100 side of the market. But guess what? It is also wireless Bluetooth SPC data output capable. In fact, I did all of my tolerance and data testing connected to my Amazon Fire tablet, which is pretty cool. Make sure you stay tuned for the end of the video where I do all the data testing. And it also has auto on. I know a lot of people want that feature to have it automatically turn on when you move the measuring face there. It does use a little bit more power with that feature, so make sure you stay tuned for the power consumption test that I'm going to be doing here in the middle of the video. It does auto on and it auto offs. But the wireless Bluetooth output capability is something that I was really excited about. In fact, they do make a non-wireless capable version. I'm not sure if it's the same size or not, but I wanted to test that wireless output capability alongside with iGaging's new wireless SBC dongle, which you can use with your CoolantCal or your Mitutoyo Digimatic, which is a huge first in the market. Being able to just plug this bad boy into your Digimatic or your CoolantCal and press the button wirelessly to send data, that is unheard of. I have not seen any other company doing that, and iGaging once again has kind of blown away the market there. Pretty cool setup. I'm going to do a full review on that. Make sure you subscribe to the channel to get the update on that review. So as far as this one goes, it has the same standard specs as your EasyCal and pretty much every other digital caliper on the market. It has accuracy down to 1/1000th and resolution down to 1/1000th, which is the standard go-to set of specs. It is not absolute origin though. So if you are looking for an absolute origin caliper, I still recommend the CoolantCal. But if you're looking for something to use right alongside your BMCs or your CNC lathes where they will be exposed to coolant, this is going to probably be my new top pick. I can't wait to buy the new the non-wireless version and see how it compares in size and weight. This one does have kind of a boxy look to it. It's pretty much the same size and weight as the other calipers. It's a little bit deeper than the Mitutoyo, about the same, maybe a little bit more than the CoolantCal, and it has about the same weight, but it kind of has this like boxy squarish look. But it's got kind of like that retro look too. I kind of like the look of the CoolantCal a little bit better, but the fact that you're getting auto on, auto off, wireless Bluetooth capability, and coolant proofness is pretty much the most features you could possibly ask for. The only thing I would like to see is absolute origin. If they put absolute origin and fractional mode on this bad boy, it would be hands down my #1 pick. And I'm sure iGaging will probably do that pretty quick here. It does come with a certificate of calibration, meaning someone at the factory did individually check this particular serial numbered product to make sure it met its rated tolerance, and that's a good thing. If you go out and buy like a Nico or Harbor Freight, you're pretty much the last step in quality control. With some of the mid-range companies on the market, they do that extra testing for you, like you'd think anyone else would, to make sure you're going to get a product that meets its specs. So we're going to test this in every possible way. I'm going to drop it in a bucket of coolant. I did all of my data testing. That's going to be at the end of the video. Wireless and power consumption all in one video. So make sure you watch the whole thing. Okay, to test the current draw, I've got my multimeter set to microamps, not milliamps, but microamps. I've got 2 AA batteries in series to give me about 3 volts, and I had to set up a dummy battery here to get to the contacts. The positive lead is way back here in the back, and I did not have any kind of micro clips that could get on there and stay on there. So this dummy battery setup is working pretty good there. I'll just connect the positive lead here, and it is on now, and with the wireless constantly pinging, it jumps all over the place. We're getting anywhere from like 86 up to 150. Every once in a while I see 160. So your average amp draw while on is going to be about 120. Okay, and I've tested that connected to wireless. I've sat here for 10 minutes trying to see if it was stabilized, depending on whether it was connected or not, and it always seems to jump around exactly like it's doing now. Let's go ahead and turn it off, and this is the interesting part. It actually draws a good 153 to 155 microamps while off. That's 450 microwatts. And the reason it draws so much when it's off is because it is designed to turn on the instant you start moving the measuring body. So those of you that asked for that special feature of being able to have it turn auto on when you start moving it, you're sacrificing battery life exponentially. That's a lot of standby power to be drawing. So you can compare that to a Mitutoyo that draws 7 microwatts while on, or 3 microwatts while on, and you can see that this is drawing a lot of power. You are paying in battery life for that wireless and that auto on feature. Not a big deal. Just take the battery out when you're not going to use it. It's not that big of a deal. And those of you that do need a coolant-proof caliper and you are using SBC data output, this is still going to be one of your best options here. Alright, I'm out in the shop and I've got the CoolantCal here and a bucket of coolant we just drained out of a truck. That's dirty coolant. This is Ford Gold coolant out of a 6-liter diesel truck. And I'm going to go ahead and take the battery out. This is actually the second time I've shot this video, so it has been in the bucket already. And I'm going to go ahead and pull the battery so you can see. I did dry it off with a shop rag, but we'll see if there's any water infiltration there. And look at the O-ring. You can see some liquid around the O-ring itself, but nothing has gotten past that seal. We'll go ahead and reinsert it and do the drop test again. Make sure it's all the way in there. Coolant is especially bad because it's very conductive. It's got a lot of total dissolved solids, and it's basically like sugar water. So it's very hard on electronics, whether it's a pressure transducer or a caliper. Being coolant proof is a really notable feature. So let's go ahead and reset it back to 0. And we'll do got a 1-inch gauge block here. Measure that, put it in inch mode. And there we go, we're reading 105, pretty much 1. All right, here we go. Probably dry it off a little bit here. The first time I did the test, I did not dry it off, and the liquid was actually throwing off my measurements a little bit. So this time I figured I'd go ahead and dry it off before I do the test measurement. But it has been in the liquid twice now, and it's still functioning the way it is supposed to. So let's go and repeat our test measurement here. 0. And gauge block. Yep, that's right where it was before. All right. So plus, thumbs up on the coolant proofness. It does the job and works.